And I'll be going over our presentation on crash recovery and replication strategy in MySQL on behalf of my group. So in order to understand the basics of our topic, we need to understand what replication is and what that means in MySQL. So replication enables data from one MySQL database server to be copied to another. So in the case of MySQL, there are two different types of servers. There are master servers and slave servers. Master servers are able to perform different write operations, whereas slaves are only able to read. MySQL offers two different kinds of replication. There's asynchronous and synchronous. In this project, we'll be focusing on asynchronous replication, and that's when masters do not have to wait on the slave to completely catch up for the database to grow. So the slave doesn't need all those transactions in order for us to continue inserting into the master. So there's something called a MySQL replication leg that will keep track of that so administrators can know how far behind the slave is. Synchronous does have to wait, so there is no such thing as replication lag, and you cannot insert into the master until the slave has caught up. Asynchronous is also the default type in MySQL. So there are multiple different ways that you can set up replication in MySQL, and we're going to be covering three different strategies: master-slave, master-master, and multi-source replication. Starting off with master-slave replication. So this replication strategy consists of one master and one slave, and it is important to note that this replication strategy is only going in one direction. So we have data in the master and it's being replicated over to the slave. If the slave writes into its databases that are replicated from the master, then we might encounter some problems because data will technically exist in the master but not be visible. So when data is duplicated in databases on primary keys, replication will break because these primary keys need to be unique. So it's really important to be very careful when inserting data in this replication strategy. If you insert anything in the slave, it might not automatically break, but if there is a duplicate entry, then it will. The next replication strategy is the master-master replication. So this strategy has no slave and two masters, and both servers are replicated from one another, and writing can be done on both ends. So the great benefit of this strategy is that writing loads for users and applications are way more balanced. So imagine you had 1,000 different users and applications trying to access a database in one server. The server is going to overload if that happens. Now imagine you have two servers with data that's completely identical, and you have 500 users accessing one and 500 users accessing another. All the users are still accessing the same data. However, the loads are balanced between the two different servers. So this is why this strategy is really great. The one thing to note about this strategy is that once a server is participating in a master-master relationship, it cannot participate in another master-master relationship. It can still participate in other replication strategies, just not another master-master. The last and final replication strategy that we will be covering is the multi-source replication, which can also be referred to as multi-channel replication. So this is when one slave can have multiple different masters. So for example, imagine we have a slave server, and the slave server wants to have both database X and database Y in it. Now imagine we have two masters. Master 1 has database X and master 2 has database Y. So the slave is able to replicate database X from master 1 and database Y from master 2 if it would like. It will just have two different replication channels, one going from one master and the other one going from the other. In the case that replication needs to be repaired, we can always find the error in any error log or in the MySQL show slave command beside the last error variable to come up with a solution on how to recover replication. One example is set global SQL slave counter, which will skip over any binary log transaction. So if you execute any bad query, you can skip over that transaction by using that command. So now that we've learned a little bit about what MySQL replication is, the goal of our report is to learn actually how to set up a MySQL database management system and to set up these different replication strategies that we had discussed, we plan to record our observations, reflect how they react to different updates and inserts, and just test these different replication strategies and see how they actually operate. The reason why we chose MySQL is because it is one of the most industry standard database management systems, so we thought it would be really useful to learn how high availability works in MySQL. So just to briefly go over the setup of our environment, we created 3 different virtual boxes using Oracle VM Virtual Box Manager. We created 2 different masters and 1 slave, and we installed CentOS OS 7 and MySQL 5.7 on it. There was an internal network adapter that had been set up in each virtual machine in order for all 3 of these boxes to be able to communicate throughout one another so that we could actually set up the replication. We had to set up a bunch of different config files and things like that on the networking side. On the Linux side, to make things a little bit easier, we used hostname.ctl to change the name of our hosts so that whenever we set up replication, it was easy for us to understand what 2 servers were involved into it. So we changed them from the IP addresses to master 1, master 2, and slave. Once we had everything set up, we created 2 different databases, one called Students in Master 1 and one called Courses in Master 2. This is the query that we use to create students database, the primary key being the student number. And this is the query that was used to create the courses database, with the primary key being the course code. So the first replication strategy that we set up was the master-slave replication between master 1 and slave. The first step to setting up any replication is making sure that the user permissions are in check. So in this case, we need to make sure that there is a user on the master server that is going to be used by the slave server to read transactions in order to replicate data whenever new inserts happen. So this type of user isn't just a normal MySQL user, it's called a replication slave. So we have to grant that permission. As you can see in that 3rd line, we granted replication slave to the user replica slave. The next step was to back up everything that was in master 1. In this case, it's just the database students. We used a command in the command line called MySQL dump, and what that's going to do is take a full backup of the database students. So the important point to note out here is the flag master data equals 2. That's super important because inside of this file that we created, we're going to have the MySQL bin log and position number showing, and we're going to use those to set up our replication. The 3rd step is to copy the database file, the backup file in master 1 to slave, and we used SCP. So we executed this in the slave server to essentially move the backup file from the local host to the remote host. The next step, once the backup file has moved over to slave, was to restore that into MySQL. So we unzipped that file and then piped it into MySQL-u root-p to create the database inside MySQL. And then we were able to set up replication, and the way we set up replication is by executing a change master command, and this is what's going to cause the channel to pop up in MySQL. So we had to specify all these different details, what the master host was. In this case, it was master 1, the port for MySQL, which is 3306, the user that we're using, the password that we created for that user, the bin log value that was found in the MySQL dump backup file, and the log position, and then we started the slave. The next replication strategy was the master-master replication between master 1 and master 2. So similar to the previous replication strategy, we had to create those users on both servers because they're both masters, and then we had to create a MySQL dump on only one. So in this case, we created a MySQL dump in master 1, and we transferred that file over to master 2. We then restored the database into master 2, and then we configured that change master command to execute in master 2, similar to how we did it in the previous replication strategy. The difference is now in any database server in MySQL, you can execute a command called show master status. This will provide you with a master log file and a master log position that we then use to execute in master 1 to establish the master-master replication. It's important to note that we also created the database in master 2 after this replication was set up, so then the database was then present in both database servers. So the last and final replication strategy that we set up was the multi-source replication. Similar to the other two strategies, we had to create users in both masters, and we had to also create two dump files for each one of the masters, master 1 and master 2, because the goal of this replication is to have one database from each master replicating over to the slave. So because the slave is going to have two different masters, we had to be able to differentiate by creating two separate channels. An important point that we had to do was we had to change a variable inside of the MySQL configuration file called slave parallel workers, and we had to make sure that it was greater than 0 in order to implement multi-source replication. So these change master commands look just about the same as they did in the first replication strategy, the master slave. The only difference that you can see is at the very end, there is a part that says for channel. So by putting this in, it's saying that this one is for channel master 1, and that the second one is for channel master 2, and that's how we're able to differentiate the two different channels. Once we had all of our different replication strategies all set up, we were able to begin our testing. So we had master 1, master 2, and slave, and they were currently set up as they are in this diagram. So we started by inserting data into master 1 into database courses, because it has both courses and students in it at this point. And we want to see how this would behave in both master 2 and slave. Once we inserted all of that data, we were able to see and record the counts before and after the insert in master 1. In both master 2 and slave had the same output, where before the count was 8, because that's how much we initially put into the database before we started setting up any sort of replication at all. And then afterwards, after our inserts, there was 16 records. For our second test, we inserted data into our students database in the table names to see how master 1 and master 2 would behave. After performing our inserts, we compared the count rows in both master 1 and master 2 and compared it to slave. We found that slave, you could see the new counts, so there was 11, whereas in master 1 and master 2, it was the same as it was prior, only 9 records. For our final test, we want to see what would happen if we reinserted the test 2 data into now master 2 instead of slave. We inserted that and we got a duplicate entry error, and we saw inside the replication so slave status that even though slave IO was running, slave SQL was not running, so that meant the replication had stopped. So because there was only 2 duplicate entries, we were able to skip over the transactions that were in the binary logs, and we did this using the SQL slave skip counter, and then replication was able to work again. So that concludes our testing. So just some things that we learned. So in order to set up replication, a high level of knowledge of networking system, Linux systems, and database management configurations is important. So it isn't just about understanding MySQL and knowing how queries work. We found that replication could be set up in a variety of different ways. This setup is chosen and would depend on the client's needs and the most efficient way to satisfy those needs. Replication within a database needs to be dealt with a high level of accuracy and consistency in order to avoid costly replication breaks. As we could see in our test 3, it was so easy for us to just break it by re-executing just only 2 insert queries. So even though we did reach our goal in providing a strong introduction to how replication in high availability works and behaves in MySQL, our testing only investigated a very small part of replication in MySQL. So in the future, we hope to implement more complex replication strategies and testing those in regard to recovery. We also hope that we will learn more about the configuration files so that we know how we can customize our replication to better